I think it's 1 minute past start time, so we should get started. We have about 23 people and we have about 90 minutes of the agenda. Before we get started, we need a minute taker and JavaScript. The links for both are here. Anyone?
So perhaps, well, sorry to ask recently, but perhaps Anna, I don't know if you might be able to take a few minutes, perhaps if more people can join. So this should be actually some collaborative process. And you can see actually there's the CodeMD link on the slide. You can also find it from the agenda page. And yeah, let's hope that people can contribute to minute taking.
Thanks, Lauren. I am guessing you're going to take the minutes in the CodeMD. I will also be helping. Anybody who's on Java who can be the JavaScript? All right, should we get started? Yeah.
Yeah, I think so.
So here's the note well. And this is our agenda for the day. We have about 90 minutes of agenda items. Anyone wants to add or modify this?
So perhaps just one comment here that we actually requested a 1 hour slot, but we were given a 2 hour slot. So I guess for avoiding conflicts with other working groups. So yeah, it turns out we have more flexibility so than in other times.
All right. A quick update on all the active drafts that we have. Since the last time we met in November 2020, we have 4 RFCs published for the work we did in the last few years. Congratulations to the work group. And for the rest of the drafts that are in various stages of IESG processing, we will have a quick update in the discussion today. For the packet delivery deadline, that's in the RFC editor queue. Eric, do you want to give a quick update on it?
I can report that it's in cluster 310. Many things were blocking on cluster 238 being published, which finally happened. And the RFC editor seems to think there are still 3 references that need to be published first, I think. 6-tish architecture, DetNet architecture, and role routing dispatch. And I wonder if that's actually true. Because there was another case in a quick document where there was, yeah, so DetNet architecture is a normative reference, as is role routing dispatch. So if you want, I can email the RFC editor, but it's part of this cluster 310, and I will paste that link in the Jabber. So it's you can see there what its 3 dependencies are.
All right.
If you want, I can ping them, but I suspect that the answer will be A, many things were blocked on 238, and B, the other dependencies are still in process of being worked.
Okay. Cool. Thanks, Eric. So the next status update on the draft that we have will be on the BLE mesh. Carlos?
So perhaps one point before starting with this presentation would be, again, Eric, if you could provide us some feedback about the NFC draft, because there was some message from Benjamin who had a discuss on the document in October, I think. So it would be good perhaps if you have any updates on that.
The NFC draft? Oh, so not the Bluetooth mesh.
Yeah. If you show perhaps the intro, yeah. So it's the NFC-17.
Yeah, this is in my queue. There was an update, and let's see. One of the blocking comments, well, from someone who is no longer on the IESG, was centered around the fact that the NFC spec is not public to read. I don't suppose that's changed at all, and I don't suppose it's going to change. Please speak up if that does change.
So I'm not sure if there's any co-author from the NFC draft who could explain if, for whatever reason, now the NFC specification is available, is open.
And apart from that, I don't think I've seen. Well, sorry, I don't remember any. Yeah, I have to check. I don't see that I've seen any response that's closed out all of Ben's issues. But I have to admit, I have also not followed closely. Let me check.
Okay, thank you. So should we then move to the next slot?
Yeah, I'll have to catch up on what happened with this document.
Okay,
see
thank
if
you.
I can ping Ben.
Thank you very much. Okay, so yeah, then, this is Carlos here as a working group participant. I'm going to present the status of and the proposed updates for the document entitled IPv6 Mesh over Bluetooth Low Energy using Ipsp. Next, please. So first of all, let's take a look at the status of the draft. So since the last meeting, there were a number of pre-ISG reviews on the previous version of the draft, which was 08. Those were the reviews from the Routing Directorate, IoT Directorate, General Area, and Security Directorate. And well, we would like to thank all the reviewers for the very helpful feedback. And most of the comments were editorial, perhaps except for the review by Dominique from the IoT Directorate, which included also a few technical points and questions. So after that, we produced -09 with the aim to address the comments received. And also we hope that the answers provided by email were sufficient to address the different questions. So once again, thank you to all the reviewers for the feedback. Next, please. So then revision 09, which is the current one, the last one, has recently been reviewed by the ISG. This is a couple of weeks ago. So you can see on the slide some figure showing the summary of the ballots by the different ISG members. So there are two discussed points, one by Martin Duke, another one by Benjamin. And then there are a few comments, some of them also by Benjamin and by Martin Bigorre and Robert Wilton. So next, I will present the different discuss and comments provided and which is the approach from the authors in order to update the draft to try to address them. So next, please. So the first discussed point is the one by Martin Duke. So it's about a paragraph that we have in section 3.1, which focuses on protocol stack. So we have a sentence that states currently that this specification allows using different MTUs in different links. And in the same paragraph, we explain that if there's some application or some use case which requires the same MTU to be used in all links, then if there's a new link which appears with some smaller MTU, that might lead to some sort of network-wide MTU renegotiation cascade throughout all the links. And Martin pointed out that this could be a bad property. So the original idea here was that since the IPSP, which is the mechanism used to establish link layer connections, supports this flexibility of different MTUs, then perhaps we thought initially it could be a good idea to keep this flexibility. However, yeah, now after the feedback, and also there's another comment by Benjamin, who also points out that this same issue could be considered a security issue as well, then our approach or our proposal for the next update would be to fix this by stating that the MTU size in IPv6 mesh over Bluetooth LE is 1280 bytes. So this would be in the style of, for example, what is in RFC 4944, which is in that case for a 15.4 network. So I don't know if there may be any comment on this. Okay, so if there's no comments, let's move to the next slide, please. Thank you. So the second discussed point is by, by Benjamin. and that's on the section which focuses on label discovery. So currently we have a sentence which is that as per RFC 8505, a 6LN must not register its link local address. However, well, we need to apologize because we missed adding with the 6LBR at the end. So here the intention was to explain that we use the simplified procedures for duplicate address detection, which are offered by 8505. And then there's another point, which is that anyway, in this case, in our mesh over BLE scenario, registering the 6LN's LLA with the 6LR would be redundant, okay, because the 6LR would know the prefix and also would know the IID because it's formed based on the Bluetooth device address, which would be known at the moment of link layer connection establishment. So yeah, this would be redundant, so we would like to keep this. So our proposal for the next revision of the draft would be on the first point to explain that the messages which are exchanged between the 6LR and the 6LBR for duplicate address detection are not needed, not used. This is according to 8505. And on the second point, we would add that by this specification, a 6LN must not register its link local address because it would be redundant, and also as the 6LR already ensures link local address uniqueness as part of Bluetooth LE connection establishment procedures. So yeah, Pascal, you may have a comment.
Yeah, yes, can you hear me?
Yes.
The problem with this is the registration of the link local is used because after that you will use the link local as source to do anything like register the global address. And so this step was actually making sure that there is neighbor cache, etc. at the router. So if you omit completely this registration, what do you save? I mean, the clean way is to do it.
Yeah. Yeah. So yeah, the idea probably was trying to save like a couple of messages here, but yeah, I agree that this is actually the clean way to proceed. So yeah,
that's a normal. I mean, if you just register to the 6LR, and as you said correctly, the 6LR doesn't need to go to the 6LBR. So it's just very local between those two. If you just do it, it doesn't cost much, and then you're cleanly inside the architecture. If you try to save that, you're putting yourself in a nightmare of problems. So why would you do that?
Okay, yes, so yeah, I understand this, and yeah, so we'll discuss again with the authors and probably modify this proposal. Okay, so yeah, we will show our proposal in the next update. So thank you, Pascal, for the feedback. Then any other comment? So then we may move to the next slide, please. Okay, then now about the comments, the first one by Benjamin, still about neighbor discovery. So we have a sentence here where we state that a Bluetooth LE 6LN should register its non-link local addresses. So here the point is it's a should, not a must. And we explained already in the text that there may be some motivation when we have short-lived connections. Okay. In some cases, trying again to be a bit more efficient. And we also include the consequences of not doing so. Basically, we state in the document currently that the 6LN would be unreachable, there would be no duplicate address detection, and so on. So here, Benjamin made the question of where could he find like the complete list of consequences of not registering the non-LLAs. So, well, I think the authors are perhaps not aware of such a document compiling all these consequences. So, Pascal, I don't know if you may want to make a comment here.
Yes, two comments actually. The first one is, I'm pretty sure 8505 says it's a must. And so you must, if you make it a should, you need to indicate that you update or whatever term 8505. The reason why it's a must is also because the expectation is that the 6LR might do savvy operation, whereby if a node sources a packet with an address which was not validated as being his address, then it's valid for the 6LR to drop the packets. Like we don't shake hands, you don't tell me I'm careless, and then you send a mail saying I'm from careless. I might destroy this mail, right? So that's part of the thing. If you don't play by the rules, then as Benjamin correctly said, there are hidden consequences that don't meet the eye. One of them is savvy. If somebody implements savvy, you're screwed.
Okay, thank you. Thank you again for the feedback. Yes, so I guess, well, this came from some comment from the list some time ago as some way to try to be a bit more efficient, save a few messages here, especially for some devices which may be sending some packet quite infrequently, perhaps not expecting a response. But yeah, again, I understand the reasons, so perhaps it's clearer or cleaner to perhaps avoid these sort of issues. So,
yes, and I wanted to say something now, it skipped my mind. Anyway, yes, you would have to document why infringing the architecture is a good idea, but I can't see that it's such a good idea. It doesn't cost a much, and that was my point. You can use a very long lifetime. So you do it, and you can make a lifetime for. I mean, if your system accepts 1 year, why don't you? I don't remember what's the maximum in the signaling, but make it very, very long. And so, again, it doesn't cost so much, and you're in nightmare of hidden consequences.
Okay, yeah, so yeah, I hear you that definitely it's cleaner if we have a mast. Also, well, we'll explain this to the people who gave the feedback, trying to...
You don't even make it a must, Carlos, or you put it lowercase, because the must is already elsewhere, right? So you don't want to have redundant uppercase.
Yeah. Okay, thank you. Thank you very much for the feedback. Okay, so then we may move to the next slide, please. Another comment was on the area of header compression by Benjamin. So we state currently in the draft that an RA, router advertisement, may include a 6CO. Here, the point is that it used to be a must in RFC 7668. By the way, this RFC is the specification for IPv6 over star topology BLE. So in the text, we explain that, well, we use a may here because it would not be needed when context is pre-provisioned or provided via some out-of-band means. And then Benjamin makes the question of whether then the in-band 6CO context indication would be then superfluous. So, well, our approach would be to answer that yes, that's what happens, and to explicitly state so in the document. Yes, Pascal?
So sorry, but there are other reasons why 6CO should be there, and that's also how the 6LR signals that it can do at 505. So yeah, I understand you're trying to save something, but if you have enough bandwidth to put the 6CO, then it really should be there. Otherwise, you don't know if your router does it 505. Now, you may say it obviously does it because it always does. Then there must be another must somewhere which says any router that connects to those things must be 6LRs, because otherwise you don't know if it is or if it is not.
Okay. Yeah. Thank you. Thank you for the point. Yeah. We will, well, I guess we'll need to take into account your comment. And yes, so yeah, we will come up with some approach, some solution. But yes, definitely, if we need to signal 8505, then probably this might need to be a must. So yeah, okay, then thanks again, Pascal. Then perhaps we can move to the next slide. Okay, so then there are other comments. So the first one by Martin is about the requirements language. So basically here in the section, which is at the beginning of the document, the usual 2119 section, was intended to actually be the 8174 one. However, we were missing one part, which is the not recommended term in all capitals. So yeah, we are going to add that definitely. And the other comment is by Robert Wilton, focusing on figure 2, which is the one shown on the screen here. The first comment was suggesting to remove the bubble, which is surrounding the subnet part of the figure, because it seems this confused him a little bit. So yeah, there's no problem. Let's do it for the next update. And then there was some question about whether the top left node in that figure is that actually intended as a 6LR, or was that some sort of typo? So the answer is that yes, it was actually intended as a 6LR, because the idea is to illustrate that perhaps temporarily or perhaps more permanently, we could have something like this. That's a router perhaps for a while or for a longer time at the edge of a network. So Pascal?
Yes, I'm sorry. Just to express, I was confused. It was the previous comment was about the 6CIO, and you were talking about the 6CO. It was my confusion. Please don't worry. The 6CIO is the one that must be there, not the 6CO. Sorry.
Okay.
6CO is the compression option. CIO is the capability information option.
Yes.
So
okay.
I had a glitch in my brain. Sorry for this.
Okay. No worries. Thank you. Thank you very much. Okay. So then I don't know if there may be any other comment, anything else, because I believe this is the last, well, yeah, the last slide with actual content. So yeah, our plan is to update the draft, take into consideration all the feedback. Thanks again. And we hope that soon we may have version 10, which hopefully, well, it's intended to address the different points by the ISG members. So thank you.
So post edits will you be publishing, and would you like a review from Pascal before the ISG review continues, or?
Well, it could be valuable. I think perhaps Pascal reviewed some earlier version of the document. I don't know if, as you prefer,
I read
Pascal.
it long ago, but yes, once you've done the changes that we just discussed, if you don't mind sending it to me, I'll do a pass on it.
Well, that would be extremely helpful. So thank you very much.
Pleasure, Carlos.
Thanks, Pascal.
Thank you.
Thanks, Carlos. So is Remy or any other author for PLC? PLC goes next. So I don't. Okay, I see. Yeah.
Okay, so we are currently at the version 5, and this version is passed to the pre-IESG review. They are very helpful comments. Actually, the comments are from the general area, the ops area, and the security area, and the transport area. And we have replied to these reviews in the mailing list, and we will update the draft very soon. And the next slide, please. Yeah, thank you. The review of the security area is done by Robert, and his first comment is about the section 5 in the draft. In this section, we mainly talk about the scenarios and topologies of the constrained PLC networks. And Robert considers that this section is informational and has no impact to the implementers of constrained PLC network. And we think it is true. It is a firm comment. So our question to the working group is that if we can remove this section or move it to the appendix. So any ideas on this comment? Should we remove it or just put it into the appendix, which is the correct way?
Hello. So, Carlos speaking here. So, I think we have a similar section in the different IPv6 over full specifications in the text, in the body of the document, so not in an annex. So, I understand that, well, there are like different figures and it's quite informational, as the reviewer says. But, I wouldn't see an issue in keeping that section in the body of the document. But, well, perhaps that's just my opinion.
Okay. So you think it might be okay to keep it, right?
I think so. But,
Okay.
well,
Okay.
not sure if there can be different opinions here.
Okay. Oh, maybe let's move on. So the second comment from Robert is that the discussion of ID mapping in the security consideration is not enough. Thus, we've added more clear reference to the RFC 8065, talking about the privacy threats and gives solutions from the IETF RFCs. Robert thinks that the text is better, but needs more review from people with more expertise. So maybe he's not confident enough about this modification. And next slide, please. Thank you. So the third comment is similar to the previous one, but regarding to the stateless ID generation in the subsection 4.1. So Robert thinks that we use RFC 2464 to generate the ID from the short link layer address. And this way is conflict to the RFC 8064. And RFC 8064 reveals that a clear and direct mapping between the link layer address and the ID may have privacy issues. And actually, the problem has been solved by 6LO in the RFC 8065. The solution can be a stateless hash, which takes a short address and a secret key to increase as the input of the hash. And after the hash, you can have you can fully use the entropy of the range of the ID space. So we think that we will change the reference from the reference to RFC 8064 into the reference to RFC 8065, so that we can have a more concrete solution to deal with the privacy threats. So the last comment is about an ambiguous description on the encryption key in the layer 2. We think this sentence is redundant, and we will remove it in the next update. So next page, please. Yeah, thank you. The review from the transport area is from Joseph. In the first comment, Joseph indicated a redundant description on the reference to the RFC 4944 in two different sections. We will remove one of them in the next version. The second comment is about a concern about the 16-bit tag in the fragmentation. Actually, the RFC 4963 raises an issue that when the data rate is high, the 16-bit tag is not enough to guide a correct reassembly of the same packet. However, in constrained PLC network, which is used in the LTE scenario, the threshold data rate cannot be reached. However, Joseph suggests to add more description in the draft, just as a reminder. And next page, please. The review from the ops area is done by it's from Dan actually, and he is curious about the operation and the management of the constrained PLC network. And we've explained that the constrained PLC networks are designed to be self-organized and self-managed. And the management is different from some traditional network like enterprise network or carrier network. And actually, IETF is working on more features on the management of LT networks in the recently formed LTOps working group, which is aimed to design more features for the management of LT networks. Then suggests that we may add a subsection talking about the operation and the management of the PLC network. And we think that we can add a very short subsection talking about the PLC network is self-organized and self-managed, and how we can, for example, view the topology or all the devices online by the gateway, for example. And no more comments comes from the general area, and we will update the draft according to these comments in the next version very soon. So any comments on this status?
So thank you, Remy, for the presentation and all the feedback. So then, Eric, if we have it correctly, then we guess that once there's the new version of the draft, then the next step would be the evaluation by the ISG.
Yeah. Oh, thank you, Carlos.
Yeah, I think, Carlos, you're the shepherd for the document, so I can just wait till you tell me that draft 6 or 7 or however many updates are necessary to incorporate the feedback. Let me know when it's ready to go.
Okay, thank you. I will do.
Unless you feel like none of this seems sufficiently substantial to warrant a second last call to me. So, yeah, I think just put it on the telechat when you have a draft that addresses all this.
Perfect.
Thank you.
Yes, so we'll proceed as per what you said.
So anyone from the use case draft? Young?
Yes. Okay. Uh, this is the 6LO quality and use case document. So I want to mention that we have the change of the author's information. In the previous version, we had the take and shoot from Modio AB, but we try to contact the take and shoot, but it is impossible to contact him. So we moved him from the author list to acknowledgement section. So it is the change of the author list. Okay, please next page. Yeah, this is the history and status, and as you can see, it is a very long time ago to start this work. So now we have the 10th version. So this is the update to resolve the comment from the second working group last call. Next page, please. Yeah, in this draft, we have the six row link layer technology, G-Wave, BLE, DEX-BLE, MSTP, NFC, and PLC. And the related RFC and Intel draft are as follows, as you can see. Yeah, next page, please. Yeah, this is the useful information to compare across 6-row link layer technology. So in this table of comparison, we have the G-Wave, BLE, DECT-BLE, MSTP, NFC, and PLC. And we try to analyze the usage of each technology and the technology and subnet and mobility requirement, security requirement, coupling requirement, and etc. Next page, please. Yeah. During the second working group last call, we got comment from the 5-person, Kerry Lin and SVR Anand, and shared Madi Darudi and Pascal Subars and Hao Jing Ray. So thanks for their good comment. So in this phase, I try to how to we resolve of each comment. The first one is the comment from Caroline. So as you can see, it is the kind of the typo and the mistyping. So we change the text as the Caroline suggests. Okay, next page, please. Yes, this is the command from SVR Anand. So the first command is that the title of the section 5. The original, the title was Guidelines for Adopting IPv6 Stack 6LO and 6LO fan. So he suggests that this draft is about 6LO like other sections. So it is better to use only 6LO in the section title just for consistency. So we followed his suggestion. So we delete the expression of 6LO fan in the title and change the title into Guidelines for Adopting IPv6 Stack 6LO. And the second comment is that the certain part of the same section requires a bit of rewording so that the reader feels it is a 6LO document rather than a summary of the 6LO PAN protocol. So he expressed the concern of the usage of the 6LO PAN. So to resolve his comment, we add the following sentence and at the beginning of the section. That is, 6LO aims at reusing and or adapting existing 6LO PAN functionality in order to efficiently support IPv6 of a variety of IETF technology. And the third command is that for 6LO network, they use wired link technologies. A short note on whether and how 6LO PAN can possibly be adopted helps. So we think that we have a text of the wired technology that is a PLC. So in the PLC section, there are already the relevant text. So we don't need to add another text for the command. And the fourth command is that the emergence of BACnet IP as an alternative for BACnet MSTP cannot be ignored. So he suggests the usage of he suggests to add the BACnet IP. So we add a couple of sentences at the end of the first graph of the first paragraph of the section 6.4, that is the MSTP section. And the last comment is that refer to section 6.2, the use case of Bluetooth LE, smartphone-based interaction. The need for 6LO for this use case is not coming out clearly, so it would be good to explain. So we add the sentence in the use case of the BLE section. That is, the 6LO enables this use case by providing efficient end-to-end IPv6 support. Okay, please go to next page. Yes, this is a comment from shared Mati Taruri. So it is a little to the correct the typo and the mixed expression. So we follow his suggestion as like this. Okay. Please go to next page.
Thanks for addressing the comments.
Oh, okay. Okay, thank you. And this is comment from Pascal Subars. So I personally thanks to Pascal Subars because he helped to improve this draft because he gave many comments. So I want to explain one by one. The first comment is that he feel that there are some should be passed on the grammar by a native speaker. So I and Carlos to our best to improve the writing of the document. So and the second comment is that there are the mistyping of the 6-row pen, so we changed as he suggested. And the third comment is that he suggests to update dev discovery optimization for 6-row pen RFC 675 to include RFC 8505. So we update the reference of RFC 8505. And he suggested the section 2. So section 2 was to convention and terminology section. So yes, we checked that this is the informational draft. So we delete section 2. And the fifth comment is that he suggests that the Bluetooth SIG and IP link. So we discussed this issue from among the authors. So we conclude that the IP link, it is difficult to find the information in the public space. So there seems to be no public available information regarding the IP link at first. So we would like to add information on that, but only as long as it is public available. So it is our response. Okay, go to next page, please. And the sixth comment is that the G3 PLC is that. So G3 PLC used on escape to the 6-row pen, and you discuss in the section 4.1. So why not a word with a port reference here? So as he to resolve this comment, we add a short text of G3 PLC and a reference. And the seventh comment was that the section 4 has GDAN 9903 and the netricity, but he want to add the YSUN. So you know, in the previous version of our draft, we have the YSUN section, but the previous draft. Could you hear me?
You're back.
Yeah, thank you. So in the previous section, we had the YSUN part, but to make it compact of our draft, we delete the YSUN. And the YSUN is based on IEEE 82.15.4 technology. So, but so Pascal suggests that he is better to include the YSUN section. So we restore the section of the YSUN in the update version. And the eighth comment was that the factory automation. So we found that the text of factory automation was already exist. So we used to no action for this comment. The ninth comment was that the missing of the thread. So I know that the thread also use is based on IEEE 82.15.4. So we have some concern about that this document, this draft is targeting on the 6th row, not the 6th row pen and the IEEE 8.15.4, but to follow to resolve this command, we add a section of thread. And the 10th command was that the section 5 is really neat and useful, so he loved to see it earlier. So we adjust the location section 5 earlier. Okay, next page, please. And 11th command was that the 6th row pen at the ND, and he suggests to broadcast avoidance the bleed. So to resolve this command, we follow his suggest and we add the new bleed, broadcast avoidance. And the 12th command was that some the host route interface and the proxy discovery there. So we add host to router interface bleed and proxy neighbor discovery bleed. And the 13th command was that it is related to APND, so we update the reference. And the first command was that the 6th row pen ND and the address assignment related. So we update the relevant text in the address assignment bleed. And the 5th command was that, but we think that we don't need to the critical action. So okay, go to next page, please. And this command was the housing the drag. So he suggests some typo and mixed expression. So I think that it is a little minor. So we change the text as he proposed. Okay, next page, please. So it is the conclusion of our TOC. In the previous version, we had the section 2 convention and terminology, and the update version, we delete the section 2, and Pascal says that the previous version, the guidelines for adopting IPv stack, it is located in section 5, but in the new version, it is moved to in the section 3. Okay, next page, please. Yes, as the Pascal's command, we update the whole paragraph to improve the writing of the document, and we add 2 6-row deployment scenario. One is the YSON, and the other is the thread. And we update the PLC part to include IEEE 1901.1 and G3 PLC. Okay, next page, please. And we found that after submitting the 10th version, we had a comment from the Tero Kibinin. He suggests to include IEEE 802.50.9, but unfortunately, in the auth, we don't have any expert regarding IEEE 802.50.9, but in the update version, we tried to resolve his comment. So thanks, and so that's all. Thank you.
Thank you. I don't see anybody in the queue, so let's move on to the next topic. Carlos, sheet header compression.
Okay, hello again. So again, as a working group participant, I'm going to give this presentation about the idea of using chic header compression in 6LO environments. Next, please. So first of all, about the motivation for this idea, we have the RFC 6282 has been the basis for header compression in 6LO PAN and also in 6LO. This RFC was designed for 15.4 as the target technology below IPv6, and it has also been adapted or reused for relatively similar IoT technologies, such as the ones that we deal with in 6LO, like Bluetooth Low Energy, NFC, and so on. So with 6282, it is possible to compress an IPv6 UDP header of 48 bytes down to a size of 7 bytes, assuming the best case and with global addresses. And on the other hand, recently there has been the publication of another specification, which is RFC 8724. This is also known as CHIC. This stands for Static Context Header Compression and Fragmentation, which is a product of the LP1 working group. So this specification provides adaptation layer functionality and offers both header compression and fragmentation functionality. So this specification, CHIC, has been designed for technologies which are even more constrained than the ones typically handled in 6LO PAN or 6LO. Specifically, those are the LP1 technologies, low power wide area network technologies like Sigfox, LoRaWAN, Narrowband IoT, and so on, which are actually more constrained than the typical 6LO or 6LO PAN ones. So if we focus on the header compression part here of CHIC, by using CHIC, it's possible to compress a 48-byte IPv6 UDP header down to a size of something like just 1 byte. Again, assuming the best case with global addresses. And this is because CHIC uses static context, which exploits a priori knowledge of header field values. So if one knows beforehand which will be the values of the different header fields, then it's possible to achieve this very efficient compression. So next, please. Okay, so then if we look at the application layer protocols as well, it turns out that there has been no 6LO or 6LO PAN defined header compression for an application layer protocol like CoAP. And in that case, if we want to compress the IPv6, UDP, and CoAP headers, the result would be a size of 11 bytes if we use RFC 6282, like the 6LO PAN traditional one, and we cannot actually compress the CoAP header. So that's assuming, again, the best case with global addresses and assuming that there are no CoAP header options, then the resulting size would be 11 bytes. But it's actually possible to use CHIC to compress the header of CoAP. And in fact, there is a document that just recently entered the RFC editor queue produced by the LP1 working group, which specifies how to do so. And in that case, it would be possible, again, with no CoAP header options and best case global addresses, to compress the IPv6, UDP, and CoAP headers down to a format of just 2 bytes. And well, actually the improvement could be greater, meaning that the uncompressed header size in CoAP can be of greater size depending on the use case, okay? But well, assuming these conditions, we would have the results that we can see on the slide. So next, please. So here we can see on the left, we can see the protocol stack. That's the traditional 6LO PAN based protocol stack. And on the right, we can see what we plan to do here. And the idea would be that, well, perhaps in some cases, we might want to use CHIC for header compression instead of the traditional 6LO PAN header compression. So to be clear, the idea would not be trying to obsolete 6LO PAN header compression. The idea would be offering an alternative way of doing header compression, but now in environments which typically would be considered 6LO or 6LoWPAN-like environments. Next, please. So we might make ourselves the question of, okay, should or might we use SHIC header compression for this kind of 6LO, 6LoWPAN environments? And well, some of us believe that the answer is yes, at least for some of these environments. And there's related background materials in the couple of individual drafts that you can see on the screen. And also these ideas were already presented in a couple of previous IETF meetings. And we believe that there was positive feedback actually from this idea. And well, if the answer to the question in the title is yes, then for the sake of coexistence with existing networks, existing implementations, and interoperability, we need to signal when SHIC header compression is used. So to do that, we can follow the approach shown on the slide, which is defining some frame format, which in this case would be placed as the layer 2 frame payload, which would correspond to some encapsulated SHIC compressed packet. And as you can see, the first field, the leftmost field, would be a dispatch indicating that what comes next is a SHIC compressed packet. And at the right of the dispatch, we would have the SHIC packet with the possibly compressed header, and then the payload. Next, please. So there is one specific proposal for the dispatch that I was mentioning right now. So the proposal is in the individual draft that you can see in the first bullet. And the idea here is to define some specific 6LoWPAN dispatch type for SHIC. So here the proposal is to use the RFC 8025 concept of page and use actually dedicate a whole page for SHIC to keep low overhead, and considering that currently pages are mostly unused except for page 0 and partially page 1. And the idea here would be to use the paging dispatch, which is the 1 byte pattern that you can see starting by 4 ones and then a number of, well, 4 bits to be determined. We could use that as the SHIC dispatch. So the 6LoWPAN dispatch type, which would indicate that next, what comes next is a SHIC compressed packet. So then, assuming that we follow this path and we use this sort of dispatch for SHIC, then, okay, which could be the potential performance improvement that we might achieve, still considering the same conditions mentioned earlier? Well, in the traditional way, we could compress IPv6 UDP header by using 6282, and then we would have the CoAP header. And under those conditions mentioned, the size of the resulting header would be 11 bytes. Whereas if we take this 1 byte SHIC dispatch plus then the SHIC compressed header, which would be of 2 bytes in that case, then the result would be a format of 3 bytes. And of course, well, we have this 8 byte difference. So we are sending or receiving less bytes with the SHIC approach. So in that case, imagine that we have some battery operated device, which is periodically sending some message, some packet. Then it would be possible to, well, in theory, to achieve a battery lifetime increase by up to 40% over 15.4, considering any topology like, well, for example, mesh topologies. But if we consider the stat topology where there's the PAN coordinator address that is not present in the frame size, so then the frame is shorter, then the impact of this potential improvement is slightly greater, and it might reach theoretically up to 44%. So, well, we need to be aware that anyway, the improvement in a more realistic setup will be lower. So these numbers here are just like asymptotic values, upper bounds, okay? So there are different parameters and different things that will influence on which is the actual improvement, which will be lower than these numbers, like payload size, as you will see later. So improvement will tend to decrease with payload size. Then MAC layer settings will have some influence as well, because we might use short or long MAC addresses, or perhaps in some cases we don't have link layer acknowledgements, but in some others we do. Also, the actual hardware features will be relevant because, well, we usually have a non-zero sleep current consumption, even if it's typically in the order of just a few microampere. And also things like transitions from sleep state to transmit or receive also consume some amount of non-negligible amount of energy, okay? And then other parameters here could be like application settings, like how often does the device transmit a packet. Well, all this being said, well, if we can move to the next slide, please. Well, then, first of all, here we have some figure showing on the vertical axis the amount of bytes which would be transmitted or received at the physical layer under the assumed conditions with 6LoWPAN, say the traditional way of header compression, and the chic one. So, well, these are actually results not affected by all these factors I was mentioning right now. You can see there's the 8-byte constant difference here, and you can guess that, well, the relative impact of the performance improvement will tend to decrease as the CoAP payload size on the horizontal axis increases, okay? So next, please. So here we can see the maximum lifetime improvement factor. So this would correspond to the lifetime when some battery-operated sensor is periodically sending a message over 15.4. In one case, it's by using chic. And then we divide it by the lifetime when instead we use the traditional way. And this is the result. So again, you can see how as we increase, the horizontal axis label is incorrect. It's not UDP, it's CoAP, okay? And well, as you can see, the performance that can be achieved decreases with payload size, but still can be somewhat significant for some somewhat not so small payload size, okay? So perhaps this could be useful. And well, we definitely need to take into account that the actual improvement again will be lower than the numbers shown here, which are just the upper bounds, the theoretical ones, okay? And next, please. There is, by the way, if we consider the star topology scenario, there is the particular characteristic of having the involvement of the pan coordinator when we transmit or receive a frame where there's the pan coordinator as one endpoint, then the address of the pan coordinator is not included, so we can still have a little bit more of improvement in theory. Next, please. So if we want to enable something like this, then what do we need? Well, first we may need some 6LoWPAN dispatch type to indicate that what comes next is a chic compressed packet. So this dispatch probably would not be specific to any particular underlying L2 technology, so it would be quite generic. Then we may want to handle padding because a chic compressed header might have a size which is perhaps not always a multiple of an L2 word. By the way, L2 word is a quite LP1-ish working group term, which would mean the minimum quantum of information that's handled by some layer 2 technology. So for example, if we have a byte-oriented technology, then that technology can only handle bytes, right? 1 byte is the minimum amount of information. So then perhaps we might need to consider whether padding needs to be specified or could be specified like in more generic terms or maybe not. That's a question. And another point is how we provide the context to the devices. So there could be different approaches like pre-provisioning or using out-of-band means or using some sort of dynamic approach. And in that case, that would not be so static. And anyway, well, we may want to look at the solutions that may come from the LP1 working group, because this working group is also considering the same problem. So next, please. Yeah, then there's another option to use SHIC in 6LO or 6LO-PAN-like environments, which would keep compatibility with existing layer 3 header compression mechanisms, for example, well, 6282 and then 18138 for route over mesh. And well, as a reminder, there exist two low-PAN NHC formats defined in 6282. One intended to allow header compression of IPv6 extension headers, the other one for UDP header compression. And well, perhaps one idea, if one wants to keep using the same mechanisms for header compression like 6282 and 18138, could be to use SHIC to compress upper layer headers, meaning for protocols like UDP or perhaps UDP in CoAP and so on. And we could define like a third low-PAN NHC format, which could be a SHIC low-PAN NHC format, indicating that what comes next is SHIC compressed. So next, please. Well, so that's the end of the presentation. So we would like to know what does the working group think about this whole set of ideas? Do you think that this could be interesting to consider? Would you have any comments, any suggestions? Yes.
No, I am from the SHIC world, but I think it's a good thing to establish links between these two technologies.
Okay, thank you.
And I think so too, but I'm not independent either.
Okay, thank you, Dominique. So any other comments?
On my side, I like it as well. I like this approach that allows for interoperability between the two different technologies. Having this dispatch to indicate that whether or not it is a SHIC packet. Quite interesting work.
Thank you. Thank you. So there are a number of comments on the chat by Bob Moskowitz. Seems just a good thing to do, but receiving is always a good thing. And Sergio Aguilar is mentioning that, well, he thinks it's also a good option. So any other comments? So Laurent, are you still in the queue? Okay, then Pascal.
Yeah, I also support the work. We discussed it during the LP1 interims, and there was a discussion on whether some people would like to do the 6282 compression for IP and then use SHIC for CoAP. And for one thing, it's not very clear how you would encode that in the packet. But most of all, I believe that if we start doing SHIC, and if you support SHIC in the node, then it's better to compress both IP and CoAP using SHIC. So I'm not convinced that there is there is value in just compressing CoAP. I really support the work, but I believe the most useful case is when you compress both IP and CoAP. It's just
Yeah, thank you very much for the feedback.
Yeah, this is Dominic again. I agree with you, Pascal. I think you get more benefit by compressing everything in one go. Have some doubts on how we apply the address compression then, because in SHIC we assumed that we have an asymmetric link with a device and a core network, and here we have a peer relation, so we may think about that, unless you have an idea ready.
Well, I believe we haven't thought about this point, but yeah, definitely it's a very good point. So we'll need to think about it.
Well, if I may, when you think about the SHIC over PPP approach, we are not in the same model where you have a gateway and a device. We are in a peer-to-peer model. And it might be that the model for SHIC over 6LoWPAN is more like the SHIC over PPP, where there is no specific role. I mean, it's kind of more peer-to-peer. The bottom line is you would need to use the MAC address or something to know who is compressing what, and so it's at some point, if you want to compress something like the IP address, then you're in trouble over a multi-hop mesh, because the MAC address won't tell you what's the other side. So in your rules, you might not be able to fully compress the IP address, but SHIC is very, very open, and you can do whatever you like with it. So if you want to compress like the prefix, but not the IETF ID, you can always do that. I guess, right? For all I understand, unless I misread something.
Right, I think so. Or we may have to add another CDA, which is possible because SHIC is extensible. So it's probably minor trick to do. But yeah, we need to think about that.
Thank you, Carlos, and thanks everyone for the feedback. So, would it make sense to get any additional volunteers other than Carlos, Lauren, Anna to work on this? Will we be publishing? It does fit into our charter, right? So we can continue working on this.
Thank you. So yes, the plan would be to, well, we actually have some content in individual drafts, and the plan would be to create some maybe more comprehensive document, which could be like 0.0, again, more complete. And yeah, so anyone who wants to contribute is very much welcome.
Thanks, Carlos. Anybody who is willing to contribute, maybe we'll set up a Git for this. Carlos, would you do that? And maybe you can communicate about that on the mailer.
Yes.
Thank you. That brings us to the end of our the agenda items which we wanted to cover. Unless somebody else wants to bring up anything, this will be it. Thanks, Lauren, for taking the notes.
There's a comment. Pascal?
No, it was thanks. Thank you all. I mean, ready for bye-bye. So many thanks for the chairs.
Thank you also. Thank you very much. Okay, so if there are no other comments, then, well, probably we can close the session here. And, well, see you on the mailing list and on the next meeting.
Thanks, everyone.
Thank you. Thank you, everyone.
Thanks. Bye-bye.